Well, hi there. So in this video, we're going to learn about the production possibilities model, which is a model that allows us to show trade-offs, opportunity costs, and a concept known as productive efficiency. So let's get started. So to start off with, we're going to think about production possibilities as basically the choices that we have. And this is a model that basically shows all of those choices that a company or a country might have if we were to limit them to producing only two things. So just for simplicity purposes, often countries will be modeled as saying you're producing either consumer goods, that are things that people want to buy, or capital goods. Those are the tools and machines used to produce something else. And so you have choices. You can produce this much consumer and that much capital, or a whole lot of capital and not very much consumer. Another way to think about it would be maybe one business could produce two goods. Maybe you produce either panini or pizzas, because those are two kind of Italian foods and you might find them in the same store. And so this concept of trade-offs allows us actually to kind of think about all these different choices that one company might have. And this productive efficiency idea is that we are fully using our resources. We're not overusing them or underusing them. And so when we think about these choices, these A, B, C, D, E choices that are presented, we're saying these are choices where you're fully using your resources. You're not, for example, leaving workers not doing anything, or a machine that's a panini press that's being unused. Now, using this data at Wright, we're going to construct a PPC, a production possibilities curve. That's what the C stands for, with panini on the y-axis and pizzas on the x-axis. And so right off the bat, we already know we're supposed to do this little graph like that, and it tells us one on the y and one on the x. Now, if we're told that, we need to do it. If we put them on the wrong axes, we're actually not going to get the answer correct. So we want pizzas down here and paninis up here, or panini. Panini is actually the plural. And then it says using this data. So we're going to plot some really basic points here, right? Now, pizzas, it looks like we can make, at most of those, we can make 60. Right? So I'm going to put that as our maximum value. Now, this is really one of the only times in this class where we're going to plot points, boop, 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 all that kind of stuff. But for the most part, we're going to do just general sketches. This is one where we're really trying to understand what's going on. So the maximum number of panini is 100. So we're going to put a max value up here. And then just to keep this kind of easy, I'm going to put little hash marks in where there's kind of the quarters, right? And I just kind of know that's 25, 50, 75. This is 15, 30, and 45. Now, the choice A is 0 panini and 60 pizzas. And so that's just this choice right here, choice A. Choice B is 25 panini and 45 pizzas. Well, this is our 45 panini, and it looks like, 45 pizza, and this is our 25 panini. So we're going to go over and put a dot right here for point B. Point C is 50 panini, so that's this one, and 30 pizza. So we're going to put a dot right here. That's point C. Point D is 75 and 15. And then point E is 100 and 0. So that's point E. And then we're going to connect these dots, and it should be a straight line. Right? It should be a straight line. Now, if yours is not perfectly straight, that's okay. But why it's straight, right, is because the increasing production of one good occurs only by giving up a constant ratio of the other amount. And that actually means that this PPC shows that we have a constant opportunity cost as we move from one choice to another. For example, if we consider what we gain and what we give up when we go from point C to B. So we can do it in the table, or we can do it in the graph. When we go from C to B, right, C to B, we are gaining, going from C to B, 15 pizzas, right? Gain, I'm just going to write 15 za. And give, what do we give back to get that? When we go from C to B, we give up 25 panini. Now, from B to A, right, B to A, what do we gain? When we go from B to A, 45 to 60, that's again 15 za. And what do we give up when we go from B to A? Well, we give up 25 panini. And so the ratio of what we gain to give up stays the same throughout the entire range. In fact, if we reverse direction, like let's say we go down or up, it doesn't matter which direction it is, we're going to get the same ratio. It'll stay the same throughout the range of production. And that tells us that we have constant opportunity cost. And that's unusual, right? That would be only occurring where we have similar inputs, similar natural resources would cause that to occur. Now, in reality, it's often much more common for there to be a different opportunity cost depending on how many of something you produce. And what we mean by that is that we would say it exhibits increasing opportunity cost. In the next thing that we're going to draw, we're going to find that as we go to produce more and more of one thing, we actually have to give up larger and larger amounts of the other thing. The ratio doesn't stay the same anymore. Now, in no case will you ever give up less and less amounts, right? It doesn't work that way. So you only ever are going to have constant opportunity costs, which we just looked at, which is a straight line. The ratio stays the same. Or you're going to have increasing opportunity cost, where as you continually produce more, say, pizzas or more burritos or whatever, you're going to give up larger and larger amounts of the other thing. So let's construct this one and see what it kind of looks like. Now, in this one, it says using this data, burritos on the Y. So we'll put burritos up here and pizzas still down here. Pizza down here, and burritos go up to 75. So I'm going to put a maximum hash mark there, 50 pizzas here. And I'm going to go ahead and still do like maybe thirds on this one, 25 and 50. And then on this one, it looks like we've got a 25 here. So that'd be helpful to have that 25. And then I don't know, it's a little bit tougher with some of these numbers, but we'll kind of see how we do, right? So 0 burritos and 50 pizzas. Let's start with that one. That's point A. That one's pretty easy. Point E is 75 burritos and 0 pizzas, so that one's really easy too. But the next one, well, here's where things are going to get interesting. 40 burritos and 45 pizzas. So 40 burritos, that would be like right about here, right? And then 45 pizzas is like way over here. So again, this is just a rough sketch, right? 45 and maybe 40. Point C is 60 burritos and 40. So we're going to put 60 and maybe 40 right about here, right? I'm thinking that's about 40-ish. Probably actually even a little bit less. D, 70 and 25. So that's going to be like way up here. And 25, that's right here, right? So that's point D. And what we've seen is that it kind of bows out. It's a wonky looking one, but if we were to kind of sketch it, it would just look like this. Woo! It does that. It's kind of bowed out, and we describe that as bowed out from the origin. So when we're describing when we see a bowed out curve like that, is that as you move up, you're giving up larger and larger amounts of the other thing. Now, let's take a look at what that looks like in some numbers. Because we're increasing production of one good by only giving up more and more of the other, this shows increasing. What's gained and what's given up from C to B? From C to B, we gain 5 pizza. Let's put gain 5 pizza when we go from C to B. When we go from C to B, though, that we give up 20 burrito, right? So to get those 5 pizzas, we had to give up 20 burritos. That's a lot. Now, when we go from B to A, the very last 5 pizzas, we gain 5 za, right? We're still gaining that 5 pizza, but how many burritos do we give up? Holy smokes, we went from 40 to nothing. So when we are moving up the curve, right, going boop, 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 and it's actually down the curve in this direction, right? When you go from C to B, you're only getting a little bit here, but you're giving up a whole lot of burritos, right? And then B to A, you're giving up 40 burritos to get all those last 5 pizzas. So it's increasingly costly to continually produce more. Now, if we go the other direction, it's exactly the same. So let's kind of think about it going the other way, even though there's not a question here. When we go from 60 to 70, you're gaining 10 burritos, right? So let's say we go this way. You gain 10, you give up 15, right? So we'll say plus 10, and we say minus 15. But then when we go down this way, you get plus 5. You only get 5 burritos, and you give up 25 pizzas. So that's an incredible amount of opportunity cost for those last 5 burritos, right? You think about as you're moving down the curve this direction, which would be up this way, right? You're going to give up larger and larger amounts of pizzas to gain smaller and smaller amounts of burritos. So this illustrates the idea of increasing opportunity cost. This illustrates the idea of constant. Now, one last thing that we didn't label actually in the very first one, and we're going to go back and do it now, is label 3 points representing inefficiency and unemployment, efficient and infeasible production. And then we're going to do the second step in just a hot sec. So when we say inefficiency and unemployment, that's anything where we're not fully using our resources. So that would be a point underneath the curve. Now on this one, any point under the curve as well. So that's the same concept, unemployed resources, right? We're not fully using them. If we were fully using them, we would be on the line. So that's what we mean when we say productive efficient. We're fully using the resources. So like this one is a productive efficient point. That's a productive efficient point. Point E is productive efficient. Anything that's on the line is efficient, right? And so any of these are efficient. I'm sorry that I'm reusing E. I just realized I should have noticed that. But anyways, you can tell that this is the efficient. So maybe I just put efficient. And that means you're fully using, right? In the context of a whole economy, you have full employment. It doesn't mean 0% unemployment. It just means that you're kind of at the normal level of output. It's where potential and capacity, or sorry, where potential and actual meet. You're at your capacity. It's kind of a way to think about it. Now, if we were producing way out here, that would be infeasible. Or sometimes it's given as impossible. Like you're way out here, maybe you could do that if you ran your pizza oven like 24/7, right? And you didn't give your workers any breaks, but that's not really feasible for the long term. So you're overusing your resources. So we'd say unemployment and unfeasible or infeasible, impossible out here, that kind of thing. Now, the last part that I want to talk about with production possibilities is showing an increase in productive capacity for making both goods. Now, if we were able to produce more of paninis and more pizzas, maybe we got a whole bunch of better training for our workers or better machinery, maybe we invested in technology or what have you, it's going to cause this whole curve to shift out, right? And so rather than kind of mess up this whole thing, I'm going to sketch a little picture off to the side and say, we're going to do this. Whoop. That illustrates growth, right? So if we shifted this curve out, right, that's going to be, that's this thing, showing an increase in productive capacity of both goods. So we would say maybe that's the old point E and that's the old point A. And now the new point A and the new, right, everything gets kind of shifted out. And so we can produce more of both. Now down here, that's going to look really similarly. It's just, oops, my pen's pooping out. It's going to be an outward shift like that. Now, what happens if we were to do, though, only one, right? See here, I showed both, right? Increase both. But what if it was just the za? What would that look like? Well, down here, and you put a little in the corner here, if we only produced more pizzas, that's what this little prompt right here says, show an increase in the productive capacities of pizzas, then it's only going to shift out on that axis. And so the difference here being like we didn't get any better at making burritos, but we had an increase in production of pizza. So shifting the curve illustrates growth. Different dots illustrate different amounts of current production. So it's again the distinction between capacity and actual output. The actual output would be like, are we at point D, point I, or point U? Changing capacity, moving the line, right? So hopefully this helps you. I'll see you next time.